Algebra 2, Chapter 10.2, Multiplying and Dividing Rational Expressions. Essential question, how can you multiply and divide rational expressions? And rational expressions are where we have a unknown or variable in the denominator. We'll go over these pretty quickly. Okay, use the facts you know about multiplying rational numbers to determine how to multiply rational expressions. How do you multiply a 4/5 by 5/6? Well, you multiply 4 by 5 to find the numerator. Okay, I just put numerator of the product, multiply 5 by 6 to find the denominator. And I'm just going to abbreviate. So 4/5 times 5/6 is going to be 20/30. And then it says simplify, factor the numerator and denominator. We should see that 20 divided by 30 is just going to be 2/3. And that should be pretty simple. And now we go to basing the steps here on use for multiplying rational numbers. How can you multiply the rational expression? They give this rational expression right here. Well, here I'm going to abbreviate what it is. What you have in the numerator up here is that you have a multiplication between these two terms here. So you can take this first one, x plus 1, which I put inside parentheses, so quantity x plus 1 times 3. And down in the denominator we have quantity x minus 1 times 2 x plus 1. So you really clearly have an x plus 1 in the numerator here and in the denominator down here. So to simplify this all the way, we're going to have 3 left in the numerator over 2 times x, quantity x minus 1. And so that would be how it works out. So basically, if we factor and simplify in discussion, now we have explain one, multiplying rational expressions. And it says here, example 1, find the products in any excluded values. So you have these two first product of two rational expressions. And basically what they're doing here is factoring both numerator and denominator and then simplifying all over the place. And also they talk about excluded values here. What I'm going to do is gloss over this pretty quickly. Here's a second example they give, and they have fill-in-the-blank situations. I'm going to go straight over to this Your Turn section, number 2, find the products in any excluded values. Basically what you're going to try to do is factor anything you can and then see what cancels out. And so right now, the first thing I'm going to do is try in the numerator to find the factors of x squared minus 9. Well, this is going to be what we call a difference of squares application. So we can take this quadratic binomial and factor it using different squares into two linear binomials. So what is the square root of x squared? X. So we put x here, and then we put plus or minus. And then what is the square root of 9? Well, it's going to be 3 and 3. So we factored this first part here. And then down in the denominator, we have x squared minus 5x minus 24. We're going to try to factor that. So we set up the parentheses for two linear binomials. And we have factors of x squared are x and x. And then we have minus 5x minus 24. So we're looking for two numbers that when multiplied together equal negative 24, but when added together negative 5. So what those would be 8 and 3. Do you see that? 8 and 3 are 24, but 8 minus 3 is 5. So I put 8 here and 3, and now we're going to figure out which one is plus and minus. Well, the minus 5x, so we want to have this minus 8, because we take this negative 8 times x, we get negative 8x, and then we have plus 3, because 3 times x is 3x. So that's going to work out. So if we multiply these back together, we'll see we get this x squared minus 5x minus 24. And then over here on this other term that we multiply by, we have just on the numerator x minus 8. Now, keeping in mind that we're going to want to put everything together, I'm going to put parentheses around this 8 minus x. And now we can factor out in the denominator this 2x squared minus 18x. What is the greatest common factor? Well, I'm going to say 2x. So 2x times what equals 2x squared? Well, it's going to be x. And then 2x times what equals negative 18x? Well, it's going to be minus 9, is it? Is that right? It's 2x minus 18x. Yeah, that's right. Okay, and now we can, since we have this multiplied together, we can have everything wrapped in parentheses. So we can now just draw a line segment connecting these, and we can just see what we have to cancel. We have this x plus 3 over x plus 3 cancel. This x minus 8 over x minus 8 cancel each other. So what do we have left? In the numerator we have x minus 3, and in the denominator we have 2x times quantity x minus 9, and really that really should be it. Now, one thing I didn't do is it talked about excluded values. The excluded values we should have picked off here really when we looked at this at these denominators originally after we factored. We had x minus 8 cannot equal 0. So x is not equal to 8. We have this x plus 3 cannot equal 0. So we have x cannot be equal to negative 3. And then we have 2x down here cannot equal 0. So x cannot equal 0. And then the last thing we have is this x minus 9 cannot equal 0. So x cannot equal 9. So we have 4 excluded values based on that. So basically what you do is get to that the first thing you can to define that. So here's what we have. And all of our excluded values. Here we go. Okay, what I'm going to do is turn you loose on this, your turn, number 3, and just pause the video for a minute, have you work it out, see if you get it right. Okay, this one here, number 3, your turn number 3, I don't think it's quite as complex as the last one, but we see that for excluded values, x minus 9 cannot equal 0, so therefore x cannot be equal to 9. That's one excluded value. And also we have on the other one, x plus 1 cannot equal 0. So x cannot equal negative 1. So these would be our excluded values. And next we're going to simplify as best we can. So working below, we have x over x minus 9. And I don't see any room for simplification there. And now in the numerator here on this right side, we have 3x minus 27. So a common factor here is going to be 3. 3 times what equals 3x? That's going to be x. And then what times 3 equals negative 27? Well, that's going to be negative 9. And then we bring over here x plus 1. And then we can tie these two fractions together. And we have x minus 9 over x minus 9 cancel each other. So left we have, remaining we have x over x plus 1. So, and what else? The 3 as well. 3x over x plus 1. Okay, so there we have it. Okay, next portion we look at dividing rational expressions, which is the same thing. And divide rational expressions, change the division problem to a multiplication problem by multiplying by the reciprocal. And this is one thing that I taught 7th grade summer school. We were supposed to know it by then. So what it is, it's the principle is that dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to write down here, dividing by a fraction is the same as multiplying by reciprocal. Procal. Okay, so, and that's what this first example 2 does. It takes this second expression and turns it upside down and makes a multiplication problem out of it. Okay, so there we have that arrow of conversion here. Okay, I don't know where that came from. That's weird. Okay. All right. Here we have all the example worked out. Otherwise, it's the same thing. And then examine what makes undefined. Find the quotients and any excluded values. Well, basically what we're going to do is this. We're going to take this, we have x plus 11 over 4x divided by this. So we have x plus 11 over 4x, and we're going to go ahead and multiply by the reciprocal of this second expression here. So this denominator of x squared plus 2x minus 3, we rewrite it in the numerator. And this 2x plus 6 in the numerator, we write that as the denominator. So now we just have a multiplication problem. And it's going to be, I'm just going to work below here. So I'll put equals, I'll put x plus 11 over 4x. And I'm going to assume that we can't do anything more simple. Now it says excluded values. Now we can't divide by a negative number, so let's find the excluded values. We have 4x is equal to 0, so x cannot equal 0. And then we have 2x plus 6 cannot equal 0. So we have 2x subtracting 6 cannot equal negative 6. And now dividing by 2, we have x cannot equal negative 3. So these would be our excluded values in this your turn number 2. Okay? And then there's also going to be, we have to go look back at this original thing here too, but let's go back first. So we have, let's factor this x squared plus 2x minus 3. So we have factors are x and x, and two numbers multiplied together equal negative 3, but added together equal 2. And so we're going to have plus 3 minus 1, and that's going to work out, right? Well, here we brought that from our numerator here. So we know over there originally we couldn't divide by 0. So we know also that x minus 1 cannot equal 0. So x also cannot equal 1. So you have to look at exclusions more broadly when you divide. Okay, now our denominator of 2x plus 6, we have a common factor of 2 times x plus 3. And so we cancel what we can. So we can just go ahead and connect the fraction. We x minus plus 3 over x plus 3. So we have in the numerator, we have x plus 11 times quantity x minus 1. In the denominator, we have 2 times 4x, which is going to simplify to 8x. And I can't see anything more than what we have here. So this would be our answer. Now, I invite the viewer to look at your turn number 5 and work it ahead, then play ahead later, see if you got it right. Okay. Let's go ahead and factor what we can here. And before even factoring, though, we're just going to rewrite 20 over x squared minus 7x. And now we're going to take the reciprocal of this second rational expression and rewrite that as x squared minus 15x plus 56 over 5x squared minus 40x. And then to find our exclusions, we have our denominator in the first expression here. So we know that x squared minus 7x cannot equal 0. And then To factor this out, we would have our common factor of x times quantity x minus 7 cannot equal 0. So x cannot equal 0. And then we have x minus 7 cannot equal 0. So x also cannot equal 7. So here would be two exclusions. And then next we would have this 5x squared minus 40x. So cannot equal 0. 5x squared minus 40x cannot equal 0. And then our common factors here would be 5x times x minus 8. And they cannot be equal 0. So we would have x cannot equal 0, which we already knew from this other one. And then we have x minus 8 cannot equal 0. So x cannot equal 8 as well. And then we have this x squared minus 15x plus 56. X squared minus 15x plus 56 cannot equal 0. So so your factors of x squared are x and x. And for 56, what two numbers multiplied together equal 56, but when added together equal negative 15? How about negative 7 and negative 8? Is that going to work out? Yeah, negative 15, that's going to work out. So we've already taken care of this x minus 8 does not equal 0. We already know x cannot equal 8. So we also have x minus 7 cannot equal 0. So that would be x cannot equal 7. So look at all those exclusions we have here. We have x cannot equal 0, x cannot equal 7, which we already figured out up here, x cannot equal 8. So these three, we've already covered that one here before. So let's rewrite this expression here. We have 20, and then we rewrite this x squared minus 7x as x times quantity x minus 7. And then we rewrite this x squared minus 15x plus 56 as quantity x minus 7, x minus 8. And then in the denominator, we rewrite this as 5x times quantity x minus 8. And then we can just go canceling stuff out. So we have x minus 7 over x minus 7 cancel. X minus 8 over x minus 8 cancel. So we have left 20 over, in the numerator we have x and 5x. So it's going to be 5x squared. Well, 20 over 5 cancels to equal 4. So we're going to get 4 over x squared will be our final quotient, I will call it, when you make a division. So anyway, these are some problems to work with. We're going to have exercise set in that we're going to look at section chapter 10.2, some supplemental problems. Hope this has been helpful to you. Good luck, and thanks for viewing.